Record.
Hello, I'm Jeff Krehmer, the author of Infinite Resources, and I'm here with Roger Carlson, the author of the Saving the World Before Breakfast series of books. And together we're saving the world before breakfast with infinite resources. So, Roger, why don't you introduce our topic for today?
Yes, and since Jeff is avoiding excessive alliteration, it's got to be me saying our topic is the hype and horror of hydrogen, particularly with dirigibles. I guess to start it off, dirigibles started with hydrogen because it was the lightest gas, and actually helium wasn't really discovered until the early 1900s and wasn't that available. On the other hand, everybody's probably seen the video of the Hindenburg in flames, and that caused people to lose a lot of interest in dirigibles and particularly in hydrogen for dirigibles. And a lot of arguments been about that, and tonight will be no exception. So
I don't know if we'll have an argument. We'll just have a discussion.
a discussion of the different points. Yes. So you want to tell us the pluses of hydrogen?
All right. So to me, there are only two gases that we can use that are lighter than air in practical terms.
Mm-hmm.
We certainly don't want to be using methane because it has all the disadvantages of hydrogen and weighs a lot more. But theoretically, it is lighter than air. But hydrogen and helium are the only two options. Of the two, of course, helium is essentially inert. It's a noble gas. And hydrogen is one of the most explosive elements that we can find in the presence of oxygen. So there are definitely hazards to dealing with hydrogen. So I'll leave that there, and why don't you take up your next point then?
Yeah, well, I could say, just a little bit more detail on that. The original ships with hydrogen were buzzing around. They did well, but if you had anything that would cause a spark, you could be in serious flammable conditions. And as Jeff might mention later on, it's also a problem with the materials in use at the time where they were was it the daubing material on the outside of the Hindenburg, which was a wonderful passenger liner way ahead of airplanes. It was going all the way to South. The dirigibles were going all the way to South America and New York, and of course Germany, where the dirigibles were from. The airshippen, the airships, invented by Count von Zeppelin. He was an Army cavalry officer. When he retired, he started building these giant ships, and the model was ships in the sea. These are ships in the air. The only problem was any little spark caused a fire, and the Zeppelin company, named after the retired cavalry officer, they kept an iron discipline to keep anything from burning. In fact, they had a special smoking room where they would have fire, but it was nowhere near the hydrogen. And they checked a bunch of things. And indeed, they ran a number of dirigible delivering mail about the turn of the beginning of the 1900s. The Graf Zeppelin, named for the old guy after he passed away, I believe, it was called the Lucky Ship by the crews because it never had an accident. It went around the world, I forget, several dozen times. It even went over the Arctic, which was a dangerous thing because if you get a rain on this big buoyant structure, a freezing rain on that would make it, well, it wouldn't be a lead Zeppelin. It would be an ice-coated Zeppelin, and it would be almost as heavy.
It would go
you
over
might
like
get
a
a
lead
band
Zeppelin.
named after it. You never know. So they
Yeah.
they made it through the the Arctic, went around the world. They were doing a lot of things. Hindenburg was a much bigger version, and they were coming into was it Lakehurst, New
Lakehurst, New
Jersey,
Jersey. Yeah.
which was near New York City, and that was the landing field. There had been some scattered thunderstorms with lightning and light rain, and so that contributed to probably some sparks. There's always thoughts that the anti-Nazi resistance might have put a bomb on there. It's hard to tell what they have, what there wasn't a lot of evidence to look at because things were burned a lot. But it's
Mhm.
most likely flammable material. Once there was a little burning, there was the hydrogen and the flammable material on the skin of this dirigible contributed to a raging fire. Really, I think only about 36 people died. I think about half of the passengers and crew, and others managed to get away.
Yeah.
But it looked awful, and there'd been other worse things. The R101, which was the British, that was going to be, they were going to beat those Germans by golly, and it was connect to the empire with
Mhm.
the jewel in the crown, India, and then on to Australia, New Zealand. It would be great to connect all these things, except it was designed a little bit too optimistically. They didn't have enough power, and they were low, and they got into a storm. And somewhere in the storm or crashing into the ground, there was a flash, and everybody was lost in the R101, I believe, plus
Yeah.
a number of things.
Yeah. Yeah, so the R101, it's interesting you should mention that one. Of course, it's very germane to this conversation. Um, so when I was in university, we were required to study a book by Neville Shute called Slide Rule, which is
Yes,
basically
I've heard of that.
his biography, but a large part of it talks about engineering and the the responsibility of engineers to make good decisions and these sorts of things. And so the R101 was the British Air Ministry's version of a Zeppelin, and it was built in competition with R100, which was the
Mhm.
private industry, which was the Vickers. And anyways, ultimately, the R101 crashed and burned, I guess you could say, in Quebec after doing a transatlantic voyage, and I believe everybody on board died.
No, didn't come from Quebec. They went from England. They only made it as far as France. They were going east toward India,
Oh, okay, okay,
and so it's like I think the first night after they took off, they they got it. And
yeah,
some say the R100 might have done much better.
yeah,
It
but
was a better
that was
design.
canceled, of course, afterwards. So I agree with you that there are a lot of historically there are a lot of issues that airships have run into, and hydrogen is not an ideal lifting gas because of its explosive and flammable nature. However, I would counter that with more than 100 years of engineering knowledge and materials, understanding electrostatic forces a lot better than we did back in the day. Um, I think I mentioned to you previously that the coating on the Zeppelin was aluminum, and they used underneath it, they had a base coat of an iron oxide based material. Uh, and so the two of them together, when they burn, they basically act like thermite. And that's one of the reasons why when you see the video of the Lakehurst fire, the it just you can see the gas exploding upwards, but you also see the coating, the material around the rigid airship just burning rapidly. It was like lighting a match to tinder with an accelerant. It was and literally it was an accelerant because the aluminum and iron oxide reacted very violently together.
Mm.
Anyway, so we would know better than to do that nowadays. There is a British group right now that's building an airship. I'm just going to do a quick search because I watched a documentary on it recently.
You're talking about
And
the Airlander, I think, which is
yeah, the
been
airliner,
around.
exactly.
It had one crash, not a serious crash, but enough to crumple up some of the stuff, so they had to go back to repairs. And
Yeah, and so there's a case to be made for airships in remote areas where
mhm.
there's not regular aircraft um, use. There's a case for a micro niche that you could use for doing short trips, like for instance, across the Irish Sea between Ireland and the UK, or to remote islands and this sort of thing where there might not be an airstrip for tourist purposes. Uh, in those cases, if you're going to be carrying people and it's a relatively small ship, then by all means use helium, because helium is obviously the better choice in terms of safety. But if you're looking at using airships as a workhorse for transporting materials, I would argue that the technology exists today that you don't need to have human beings even on board. The materials can be made non-flammable. You can even put in a buffer layer between the main hydrogen and the outside air, and maybe have an area that's filled with helium or even nitrogen, a small area that's not taking up a bunch of space. But the intention is to act as a buffer from the outside so that any escaping hydrogen would be to some extent diluted, and having an inert atmosphere would prevent it from igniting. I would say that obviously we have GPS, we have artificial intelligence, we obviously can do remote control drone operations, and with the technology with being able to rotate the propulsion system, that would allow you to ascend and descend much easier.
Mhm.
And in my mind, I have methods of anchoring an airship when it gets to its destination, so that you wouldn't need a large air crew. So particularly if it's carrying a cargo or something like that, I foresee being able to lower the cargo with a sky crane, and then we might be able to do something like almost like explosive harpoons into the ground, depending on the kind of ground that might be there.
I've got some
Uh,
better ways.
well,
Harpoon
yeah,
sounds like
there are
fun.
better ways. I mean, you could do something basic like a hook connecting to a line that goes across, or whatever. Uh, One of the big issues that is always going to be an issue with airships is that they're unwieldy and difficult to handle in windy circumstances. So you would have to design it to be able to. Well, first of all, you would look at the weather before you would even start a flight, and
Mhm.
if during the trip you're expecting any dangerous weather, you just simply don't go. You postpone it until the dangerous weather has gone by. But other than that, I think that there is a good case to be made for remote communities, for supplying remote communities and locations. So, like for instance, in Canada, we have diamond mines in the Northwest Territories. The only time that they are able to get supplies in, typically in bulk, anyways, are in the winter when the ice roads are all frozen. And even then, every year it seems like they have one vehicle that falls through the ice at least. So that situation can be improved. Now, what I haven't mentioned is those diamond mines are all going to be closed in the next 10 years. So that's not necessarily a use case, but the Arctic territories in Canada have all sorts of minerals that could be exploited and mined, and especially things like rare earths. So if the United States and China continue to butt heads the way that they are, and China closes the markets on rare earth, which I think they control something like 90% of the market,
If they don't mine
Um,
it, they process it. So that's why
exactly. Well,
they're
they do both.
dominating the market.
Yeah. And because,
Communism met robber baron capitalism in Beijing.
and part of it is because they're willing to overlook a lot of environmental standards that other countries aren't, in the interest of developing their economy. And you know, having said that, you can just go and look at Colorado or any of the mines in Canada that were done in the 1800s, and it's not like anyone was the least bit concerned about runoff or tailings or anything like that back in the day. So we've all learned those lessons. China is going to learn them the hard way if they continue with those practices. So
Mm-hmm. Okay, well, I'll carry on from you, and I'll do the agreements with you on a lot of things. There are materials now that are lighter than they're like composites. They're lighter than the aluminum girders because I'm talking about using a what they call rigid dirigible. Since they had an outer skin, and the inner side, the inside of the craft has got gangplanks, and you've got tanks and motors and things they're not going to get water on them, and the air bladders. You could have any number of air bladders instead of one big air bladder.
mhm.
And so if something happens like the Goodyear blimps, of which there are several, they've had reports of somebody shot arrows at them and had to shoot at them with deer rifles, so you
Yeah,
get a leak. Well, if you got an outer skin, that'll stop a lot of this stuff, especially if you're a mile or two high.
right. Yeah, it's
It
hard
it
to
has a lot of advantages.
even though it's bigger than the side of a barn, at a
Yes.
mile high, people probably don't have a good idea of the trajectory of a bullet when they're aiming at a high angle like that, and it takes a while for it to get to the destination, and so
Yeah, that helps.
but yeah, going back to the point you mentioned the air bladders and stuff, and
Mhm.
that's kind of what I'm thinking is you could use, instead of just having one large air bladder, you could have smaller air bladders around the side of it, and
Mhm.
that way isolate the hydrogen from the atmosphere, and reduce the risk of an explosion that way.
And have a number of uh, anti anti fire sprinklers. Like halon is the
Sure.
chemical in
Yeah.
mind, especially if you don't have people on board.
Yeah. Some
They
sort of inert
spray have
gas.
an automatic halon. If there's a fire, you can probably put the fire out. Or even if you have people there, they got their breathing kits. They can run in. Yeah, the halon hits it, then they have their patching kit
Yeah.
and do something. This is if they're at low altitude.
Well,
Later on,
I
I'll get
mean,
the really places. I think it's a stratospheric aerostat, but we'll get to that. Meanwhile, with the other things about making things happen, there are better propellers. They call Fibonacci propellers, things like that, which might give you another 10 or 20%, which is one of the major problems of dirigibles from uh, Count Zeppelin and Santos Dumont buzzing around the Eiffel Tower in Paris. They were
mhm,
always underpowered. And it's particularly a problem with the big airships.
right.
Well,
So
you got
let,
to put more power, and it's a problem with the Airlander. They bumped into a telephone pole or something because they were slow getting up off the
yeah.
ground, and a little wind carries them. Because, as you said, bigger than the side of a barn.
So let me address that one too. So I would envision a lot more propulsion than what Airlander has, and again with the ability to pivot 180 or
Mhm.
360 degrees. But imagine having the top of the dirigible being covered in these thin film solar panels. All of a sudden, you've got football size solar array that gives you all kinds of propulsive capabilities. Uh, And then the other thing is, if you're using hydrogen, even outside of using a solar array, um, you might get into the situation where you could use some of that hydrogen to actually run a fuel cell and provide your electricity that way. So it's interesting that and I don't think we mentioned this yet, but the rules right now in terms of airship design is you have to use helium in North America and Europe because of an international agreement that
Mhm.
was essentially championed by the helium industry, which essentially made it illegal to use hydrogen as a lifting gas. Now, here's the irony: you can use hydrogen as a fuel, you can transport hydrogen as a cargo, but you're just not allowed to use it as a lifting gas. So, my thinking is, well, okay, fine, we'll just have the entire fuel tank be in gaseous form, and we're good that way. So,
Or some of the cargo being in lifting in bladders,
yeah,
or if you're going totally non-rigid Goodyear blimp style thing, there's it's all filled with hydrogen, and
right.
in a pinch you can use it to burn with a
Yeah.
little modification to the engines.
And so what I talk about in my book is imagining, let's take an extreme example here. So you've got a 1 gigawatt power plant in the Arctic Ocean using the polar energy platform technology. What are you going to do with all that electricity? Well, one thing you can do is produce hydrogen. What are you going to do with that hydrogen? You have to get it to market. And of course, if you're going to do it by ship or submarine, submarine might be possible because you've got all the ice around you in the wintertime. But airship makes a lot more sense because it's faster and gets there. Now, one of the other advantages of the airship is when you get to your destination and you run that hydrogen through a fuel cell, you're producing water. So you can then use, maybe perch your airship up on some mesa or butte in Arizona and set up an electric plant with fuel cells, and then you can actually produce enough water to use it industrially, either for greenhouses or for human living needs and stuff like that. And I talk about what are the major cities in Arizona? Phoenix and I forget the.
Tucson.
Yeah, I
uh,
think it's Tucson. Yeah. Anyway, one of the major cities there, the average use of water is less than 80 gallons a day, for because they've gone to levels of not watering their lawns and various other things. And
mhm.
with if you're producing a gigawatt of power and transporting that in the form of hydrogen, even with losses, you're able to produce a significant amount of hydrogen to the extent that you'd be able to send like 5 huge blend or dirigibles that would be at least twice as large as the Hindenburg was, and that would provide a steady stream of water that you could use. And if you, like I said, if you do this at altitude, you can actually take advantage of the hydrostatic pressure of the water and generate some electricity that way too. But it would provide a reasonably good sized stream of continuous water coming down the mountainside, and have five ships a day come in, or 5 ships a week, transferring their loads, and you build a chain just constantly going between the desert and the Arctic like that.
Mm. Yeah. Well, grumpy grump. Also, in your book, you refer to having large freighters that can have uh, many stacks of giant ice cubes for
Yes,
transporting
exactly.
fresh water that was produced.
Yeah.
Well, those those water freighters could carry so much more water.
Oh, absolutely.
It would, with a little bit of energy, you can go over the Rockies,
Sure.
pump it, and then after that it flows back down, get some electricity on the other side.
Right. If you're looking at water like transport, certainly the water freighters that you mentioned are the way to go. Like we're talking, in a year you might be able to produce a cubic kilometer of water. That's a significant amount of water.
I don't know how
Um,
many acre feet it is, but it's a lot.
it's a lot, yeah. So a kilometer by a kilometer by a kilometer cubed,
Mhm.
and like you say, it's a lot of acre feet. I think LA County, and I forgive me if I get the numbers wrong, but I think LA County uses something like 6 cubic kilometers of water per
Mhm.
year. So
Mhm.
yeah, it's a
Yeah,
significant amount. Uh,
but
but
I will give you one more plus on dirigibles of all kinds, and that is, and now it's something else that the or people with alternate energies that say, hey, electric vehicles is the way to go. Well, hybrids is the best of both worlds.
right.
And for just a start on things, for the takeoffs and landings of dirigibles have been the killer. I think uh, von Zeppelin lost several of his experimental craft over the years when they're just getting way up and up, oh, the bottom. When you scrape the tops of the treetops as you're just just clearing the trees, but not quite. That's the end of your dirigible.
Right.
Well, with a hybrid vehicle, you have this battery. It doesn't have to be as massive, but you have a short-term high power thing. Like that's why the Teslas and other electric vehicles are just fabulous for, it's a sports car, it's quiet and zoom, it can really come off the line fast. Well, that's what you need when you're taking off, not not the immediate getting there, it's staying on the ground. Is if you're on the ground, it's heavier. It's heavier than aircraft, but you're going to start filling the bladders in there. I'm talking about a maybe maybe small enough to be like a crane sort of operation,
Hmm.
but maybe big enough to be an airship.
Right.
And as the lifting gas is filling the open the bladders, and they're filling up, and it wants to start rising. Well, that's when the the power, the main power plus electric power is sending its gas upwards. The flow propellers, however it's done, it's holding the craft down.
Hmm.
And then when the craft has high buoyancy, then the propulsion is reversed,
Yeah.
and suddenly it doesn't just slowly lift up; it takes off like a heavier than aircraft. In fact,
Right.
it'll be taking off almost straight up, so you have a fast takeoff, and you're not going to be hitting those phone poles a quarter of a mile
Yeah.
away at the edge of the
And
airport.
you can do that if you have lots of propulsion, like we were saying.
Mm-hmm.
The other thing is to use it as a material carrier, bulk carrier, whatever. It has that same problem where if you're dropping off your load, then it's going to want to go take off into the air.
Mm-hmm.
My thinking is that you should be able to control a lot of that by compressing the gases.
Yes, and I
Um,
wish I could find it. There was like I think it was a, there was a magazine called Journal of the World and Me. I think it was, and they proposed a dirigible that would compress some of the lifting gas and it'd go diving down,
right.
pick up speed, and then when it got near the bottom, it would pump the gas back out into the bladder so it'd lift, and so it'd be kind of uh, like a
Oh, so
fish
it would
hopping
porpoise
up and
basically.
down like a porpoising. There we go.
Yeah.
So you
Yeah,
could
I
do
think I
something like
remember
that.
reading about that, and they were proposing that as a propulsion method, right?
Yes, that was okay. You read the same. Well. maybe somebody else wrote it, but it's the same
Same idea.
principle.
Yeah. Yeah.
And the thing
That is
about
an
it is,
interesting
it
idea.
takes time to uh, compress or release
Yeah.
that lifting gas. Well, that's where the electric battery comes in, because it doesn't have a lot of power that it has, but it has enough to do that for 15, 20 minutes.
Yeah. Yeah.
And that gives you a lot more flexibility. And of course, the other thing is, as the dirigibles did, was you have a lot of water the first time when you're lifting up. They had a large amount of water. They would start dropping water by,
Sure.
you can drain water by hundreds of gallons per minute, and that
Very,
gives
very
a lot.
quickly. Yeah.
So between those two things, taking off is great. And then also, as I say, if you're going to if you're going to come and uh, pick up some, drop off some tools and whatnot in one of the small islands off of Hawaii.
Hmm.
That's it. You're compressing gas so you get down to, you know, 500 feet above the ground. Then you use your hybrid power. You use the regular power and the electric to push down so you can get to the ground. If you want to really just unload it with the forklifts and whatnot, while it's going down, you're pumping compressing like crazy to get it negative buoyancy so it'll stay on the ground. It has to be really negative buoyancy.
Yeah.
So a 10-mile-an-hour wind, or let's say a 30-mile-an-hour wind, not
Isn't going
unusual
to
in
blow it
a
away.
lot of places, yeah, it won't knock you over.
Yeah.
So you,
And so like the Airlander has skids that they use for that. And I imagine some sort of a skid system that, like I said, you could lower it, get it all set and kind of skidding along the ground and then anchor it.
mhm.
And then, like you were saying, you just pump up a whole bunch of water that gives you the ballast, and then the main airship can come
Yeah,
down.
on the landing, it's a little bit dicier, but yeah, a big water truck is out there. There are several big water trucks, and they're pumping water in like crazy,
Yeah.
and that makes it heavier. So it's that
Yeah.
other worry, a little unexpected 10-mile-per-hour gust of wind pushing you right up next to the phone poles.
Yeah, and so again, a lot of that could, I think, be automated to some extent. So, you know, you have a remotely operated water truck. You have all of the pumping equipment on the truck itself. So here comes the skids. They go and
Mhm.
grab them or
Yeah,
something like that, and then you have this high flow water that goes and
yeah. But then
anchors the
that brings
system.
us back to the horror of hydrogen. Want this robotic water truck with somebody in an island off of one of the Samoan islands might not have these fancy robotic things. If you
Well,
have helium, it's not going to blow up.
yeah, okay, fair enough. But I mean, the if it's isolated, it's not going to blow up either. So, I mean, the water truck. I mean, okay, you talk about the lightning and all of that stuff. Well, okay, so we just make sure that the entire surface is grounded when you put the landing gear down or whatever. You ground the whole thing, and that solves that problem, right?
Yeah, or look, if there's some extra bolts or something that fell off on the runway area where it's landing, and the skids hit the metal there, and there's a spark that flies
Oh
up.
yeah, yeah.
The helium is not going to explode
But the thing is,
very often.
uh, so the skid area isn't going to have hydrogen in it, right? So it's and the hydrogen, any hydrogen that leaks is going to go up, so it's not going to be underneath the airship. That's not a concern, I don't think.
But it depends. If, in fact, it was some bolts, probably for an American plane that killed the last one of the last Concords that flew,
Well,
and
yes,
the bolt went
that was
flying
on
up
the
and hit things. So if a bolt gets knocked up as something's kind of skidding in,
yeah,
and
that
it
was
breaks a hole in something on the bottom, they'll probably
that
say,
took down
"Well, now we're going to armor the bottom to protect what that armor costs weight."
the Air France Concorde leaving Paris caught fire because there was debris on the airfield, but the airship does not require high speed to take off. And the reason that was a
Or
problem,
land, yes.
the reason that was a problem with the Concorde was because it was traveling at high speed, and the wheel basically kicked it up, I think, into the fuel tank or in the engine area or something like that,
Mhm.
and caused the fire to start. That is a total non-issue with a dirigible. I mean, don't get me wrong, there's plenty of issues. A slight wind, like you say,
Mhm.
is a problem for landing. All sorts of concerns. But if you have enough power in
Mhm.
the system with multiple ducted fans or whatever method you want to use to get there, if you have enough power to securely ground it, and then you make it even more secure by bringing in these trucks or whatever, and then putting the ballast water in there.
Mhm. Yeah,
Um,
and your compressors are going at the same time
yeah. So
too. So the inside the bags are getting they're
less lift.
drifting
Yeah.
down to tiny, and that makes you something that can sit on the ground, barring a hurricane coming
Yeah.
through.
And I mean, again, we'd have to be smart about this in terms of if there's a blizzard coming in, or like you say, a hurricane or something, you simply don't allow the aircraft out there. Now, I'm not suggesting that we're going to have like huge aerodromes to put these things in. Uh,
Mm-hmm.
these would have to be able to withstand a reasonable storm, but using the methods you were just describing. So if you compress the gas down, so that it's not in any danger of being taken away by the storm or something, I think.
Mm-hmm.
And if it's properly anchored and streamlined enough that it's not going to flap in the wind or whatever.
Mm-hmm.
um, I think it's a viable project, and especially in a place like the Arctic has extremes in temperature, but they don't get the same kind of violent storms that we get with hurricanes and such. You can get katabatic winds coming down off the glaciers, but you're not going to get. It's very rare to get a thunderstorm in the high Arctic.
Mm-hmm. Yeah, and Katabatic. Yeah, I didn't even think about that for say, well, Alaska, and I presume there's other mountainous areas in parts of Canada. So they might have some serious storms and thunderstorms in the summer.
Mm-hmm.
But anyway, I guess the biggest thing back at hydrogen is like a necessary thing unless you have another good lifting gas. And helium is not that much less. I believe well, the thing is, hydrogen has it's a diatomic molecule, so
Right,
two atoms come together.
right.
Helium being uh,
Monoatomic.
yeah, being an what are those gas? What are the elements what are the noble
Noble
elements they used to
gases. Yeah.
call them? Which very rarely combines with anything else. It is, as you said, monatomic. There's just one element. So even though hydrogen is only 1/4 of helium in size, it's uh, it's only one half, and there's less than that. And it seems like it's
Let's put that.
like
Yeah.
only
So
10
helium.
10% more lift in hydrogen
Yeah.
than helium.
Helium is two protons and two neutrons, and so it has
Mm.
atomic mass of about four. Hydrogen, monoatomic hydrogen is a mass of one, and regular hydrogen molecules are a mass of two, assuming that you're not working with deuterium or
Mhm.
tritium.
Yeah, but it's not a simple one half of helium. It ends up being considerably less. Of
I
course,
think
hydrogen is better, but it's not one half.
I think it is actually because it's your a molecule of hydrogen is H2, so you've got two atomic masses, and helium's got a mass of four, so it's literally twice the lifting power of helium, as far as I know. I may
Hmm.
be wrong, and if I am, forgive me, but
Okay.
I'm pretty sure that's the way it works. Because
Domino, oregano, parmesan, salami, bologna. You are now forgiven.
well, thank you. But in terms of gas theory, it's based on molecules and molecular mass.
Hmm.
Um, so yeah, the number of molecules of hydrogen, like the H2, will roughly be the same number as helium at the same temperature. The hydrogen should have about twice the lift.
Hmm. Yeah. Well, that's when we'll have to, yeah, look up at our leisure, and that
Well,
to be continued, folks.
fair enough.
Meanwhile, it's your market is for moving a large amount of stuff robotically, and there is a certain charm to that. Although you were saying, you might break up your dirigible and ship it back by rail and
Well,
in
so
pieces, then reassemble it to take these huge amounts of hydrogen because your hydrogen fuel is also the cargo and
yeah,
such.
so imagine, I guess, like an airship being segmented like a caterpillar. And what I'm envisioning is you can go and it's a big fat caterpillar when you're delivering hydrogen, and then you can basically use a bunch of those segments at the destination and then just have enough to lift your equipment home, basically. And that way you can have a round trip, and much of the gas that you're using to carry the cargo is actually being left at the destination as for fuel cell
Mhm.
or some other purpose.
Yeah, and that is kind of a clever idea, and hopefully if we can recruit your dirigible aficionado. Say, hey, what do you think
Well,
about this concept? And hey, could you supply maybe a nice CAD version of what this might look like? And
I could do it actually. I'm a SolidWorks expert, but to the way of thinking, it's exactly that. You imagine like an accordion ship, and then you just when you give back home with the minimal amount of just whatever you get back to recharge, essentially.
yeah, with maybe some yeah, sort of a bunch of triangles going along, triangle here, triangle down there, triangle here, triangle there, a big girder sort of arrangement that could be uh, taken apart and then reassembled to hold the caterpillar together from
Sure.
wiggling too much in the wind.
And think of it in terms of Hindenburg, let's say. So you got the Hindenburg.
Yeah, let's not use the
No,
H word.
yeah, okay, well, just or the Zeppelin. How's that? Graf Zeppelin.
Okay.
Um, so imagine having five Graf Zeppelins, and you
Mhm.
got three on the bottom and two on the top, and they're all kind of lashed together, and they go off and do their thing. And the outer ones are basically like a balloon, and you can when they're not full of gas, they basically compress down to nothing, and then you end up with
Mhm.
one going back, and that's enough to carry the weight of all the
Yeah,
others.
and
So something
maybe
along those lines.
a big sort of non-flammable tarp that can connect them so that you'll have a smoother flow
Sure.
of
Yeah.
gas around them, especially since as a cargo craft, you're going to be going as close to the ground as possible
Right.
because every 100 feet you go up, you lose 1% of your cargo carrying capacity and so on.
Right. And the thing about something like that is it would all be designed in cells, right? So the way that rigid airships have always been done is you have gas bags inside of the
Mhm.
outer casing, if you will.
Yeah.
So if you design it properly or think about the design, you could have it so that when you suck in the gas bags, it basically pulls everything in together. And it's kind of like one of those, well, like an air mattress or something like that when it,
Hmm.
collapses down into almost nothing, and then you just roll it up and off you're off to the
Hmm.
races. Or some of these like these tents that you can basically put on the ground and push a button and they spring up to life and they're fully
Yeah.
formed. And then you just push another button and it collapses back down, right? So something along those lines,
Hmm.
only using gas
Like an
instead.
umbrella, only a little more complex
Right, right.
thing to make it work.
And it works by just sucking the gas out of it. So,
Mhm.
or filling
Okay.
gas in it.
Well, we haven't even covered all the topics, and we've gone a little more than an hour.
Okay,
It's gonna,
well then let's cover those topics quickly.
yeah. I was thinking we could do one an, uh, an entirely different story. And now for another story. It's Monty Python
Well,
would say,
keeping in mind that I'd like to send this off to some people who are interested in airships, I'd like to stay on topic if possible. So if there's any other issues that you want to bring up, let's deal with them and then.
I do. I have one entirely different, and that would be something. And uh, there were some Canadian studies on this. An aerostat, which has a lot of uses, and it would be probably at the tropopause, at the top of the tropopause, and at that level, you're about 1% of the air density of sea level. So doing a real rough back of the envelope thought, the energy needed to for air moving increases by I think it's the cube. So if you go from say 1% to 100%, you really go up by like a million. You go up a million times, and so you don't really need that much energy. And the proposal was use microwaves up to a craft. Once you get it up to that level, then it can has enough energy to move itself. I mean, to stay in position. It's fighting
Mhm.
any wind that comes. Hopefully,
Right,
at the tropopause, that's the least common high speeds.
right.
Well, if you're up there and in the Arctic area, it might be as low as 8 miles, but that's still very high above things, about
Mhm.
36 miles per mile up. So you can be looking,
Right.
yeah, call it about pushing 300 miles in a radius. So that would be something where think of it as a very high cell phone tower.
Sure.
And so you'd be competing with Starlink, things like
Yeah.
that. And the place we really need something like that is in the near polar area because you're far away from the geosynchronous
Yeah.
satellites, where a lot of people want to go to. But
Yeah.
geosynchronous satellites could beam down laser light, and then a receiver there is a very sophisticated high
Hmm.
tower. Then it can send spot beams out to different areas.
Yeah.
And being that high, it can cover a pretty huge area. And that's
Yeah.
where you start making your money.
Well,
And it's also a good thing for monitoring ships going through that Northwest Passage, which just might actually work if it warms up, according to our climatologists.
well,
So also go
it's
with the
also pretty
flows.
good at being an over the horizon radar system too.
Yeah, but if you're 8 miles up, the horizon is a lot further out.
Exactly.
And
Yeah.
so it has a lot of pluses for air traffic control and uh, and for communications because the laser light can have millions of times more data.
Hmm.
And yes, you can run fiber optic cables up through the Arctic. On the other hand, the needed capacity might increase, so the
So
lasers could probably handle it.
it would make it for an interesting light show, that's for sure. Because some of that laser, well, assuming that it's visible laser light, anyways, some of that would be lost in the atmosphere and scattered. So it would literally look like the balloon was being shot at from space in some sort of
It would be,
support system.
yeah, I mean, it would be probably much less than the Northern Lights.
Oh
We've
yeah,
already got a
yeah.
light show going. There'd be
But I
just
mean, even
one
if you think
more
of
thing
like a,
to it.
if you think of a
So you
laser
got that,
beam.
but there's more. It slices, it dices.
Oh, okay, let's hear it.
There's the Mars Society with Robert Zubrin, who I think is still around.
Yeah, he is, as far as I know.
They did this thing for years on Devon Island, where they were uh, seeing what it'd be like to live
I,
on
I think it's
Mars.
still going, if I'm not mistaken.
Yeah. Well, if you want to be more authentic, and it, of course, has to be a little bigger because people are heavy, their water supply, their food, their toilet, and everything. But uh, the 100th atmosphere is much like what Mars is like. So you could have the Mars station and you'd say, hey, Mars Society, you really want to do it, have a station on here. You can run it for months at a time and see how it works. You can also test the equipment because the temperatures regime on Mars is very much what you'd see at that
Very
altitude
similar, yeah.
and that latitude.
Right.
So that's the plus. And then Sergey Brin was one of the people who wanted to have a dirigible uh, part of his company.
Yeah.
Well, they could throw in some money. And even Elon Musk, he his original goal for SpaceX was this wild, crazy thing. I want to go to Mars.
Well, I think
We don't
that's
have
still
any,
his driving
it's too
goal,
expensive
isn't
to get there. Okay, I'll have to do my own rocket company. Well,
it?
but his goal is still going to Mars. If he wants to go to Mars, well, test the equipment. That would be the Mars station. So that would be one of these as well. And likewise, back at the high high altitude cell phone towers, the the Russians have in the past they bought their ship for their factory ship. I think that was built in, was it the Baltic country, one of the Baltic countries, or Finland? I'm not sure which. So it's like, hey, you're just buying equipment elsewhere, just like you bought a factory ship. Now this is helping connect Siberia, which has all kinds of problems connecting with things. The same problems that Canadian Arctic has.
Sure. Yeah.
So they might buy a few. And if you're doing a high aerostat cell phone, if you want a cell phone aerostat at 8 to 10 miles, then you really need a spare. So, and Canada might have several of them. It certainly have at least another one in Alaska. This is something. This could be an industry thing. You might have
Yeah.
a production rate of one or two a year of these things.
Well, just recently, our new Prime Minister Mark Carney announced uh, improving the distant early warning line, the DO line, for
Mhm.
you know seeing Russian missile launches
Mhm.
coming over the horizon over the Arctic and stuff. And so it's definitely a big concern. Of course, Donald Trump says that the United States needs Greenland for its defenses and so on, even though the Danes have been more than happy to let the Americans set up any
they
bases they want.
they just did a contract that's freezing the United States out. It's the Europeans are going to be buying their mineral resources just to be. The Danes and the Canadians are linked up now. They're not fighting over that one silly little island.
Howe Island, yeah.
They're on the same side against
Well,
those cranky folks like that invaded in 1812. But we won't
yeah,
go into that
yeah, we don't
unpleasantness
need,
of
let's
that.
not go into the politics, but I had to mention it just because it's fits in with the rest of the conversation here. Anyway, yeah, so lots of potential applications for a balloon. Even like instead of having it constantly be beaming up power, you could potentially just maybe not have it quite as tall, but have a tethered system, right? And so they're looking at tethered
Mm.
radar systems like that.
Yeah, well, they do that for maybe a half mile or a mile. Your cable starts getting pretty heavy after
Sure it does, yeah.
the first 5 or 10 miles. Meanwhile, yeah, there is one other thing which would be the same thing of hybrid electric and motor is a crane. Crane things have been proposed in the past for taking lumber out, and this would be a smaller craft that, yeah, something in the range of the size of a large sky crane helicopter or the lifting capacity of, and hopefully that you can do it with not a lot of giant helicopter blades, but a number of fairly small things, and that might be another market for these
Yeah.
things. So that would be something for your pro from Dover. Well, actually, it's more like Ottawa or Manitoba.
Manitoba, yeah. Well, I mean, the issue that we're facing in the Canadian Arctic, well, first of all, there's sovereignty. There's so few people that live up there that, Canada's claim has been challenged by other countries. Even our claim to the Northwest Passage is challenged by the United States and Europeans. So
Mhm.
it's when our
And
allies
China.
are, well, yes, China and
That
Russia,
was the
of
new kid
course.
on the block.
China claims to be was it near Arctic country, and so that's how they want to get their toes in there somehow or another. But
Mhm.
anyway, so sovereignty is a concern, and how do you overcome the sovereignty? Like, how do you resolve that? Well, you get more boots on the ground, more people living there year round, and how do you make that possible? Well, they need to have a secure source of energy, and they need to have a decent standard of living, and they need to have regular supplies and shipments and
Mhm.
transportation and these sorts of things. And I think that the amount of effort, if we put a decent amount of effort into developing a good system of airship stations. Like when I say stations, I mean like a ground station where you could hook an airship up to. Um, then all of these communities could be serviced by airship. And what I mentioned at the Arctic Energy and Resource Symposium was, you know, think of these airships as being like a fuel tank that's just floating out by your community.
Mhm.
And like I was saying, once that caterpillar shrinks enough, you go and get another caterpillar. So,
or or if you're taking diesel fuel and it's
sure. I mean, I have nothing against the use of fossil fuels, particularly as a backup system. They're reliable and they're yeah, a very
Mhm.
concentrated form of energy. So by all means, especially in the Arctic, if you're dealing with life and death situations, that's how the communities are operating now. They have, generally speaking, diesel generators that are,
Mhm.
if not their primary source of energy, their backup system. So
Yeah, and you need that energy. It's in the tropics. If you're like in Papua New Guinea somewhere, there's a village, electricity goes out for a couple days. Well, no problems. You just keep picking your coconuts and go out the boats and fish and whatnot. If you're in Nunavut and it's uh, what's it, 44 degrees below
yeah,
Fahrenheit or centigrade, they're the same at
yeah.
that temperature, but uh, gasoline won't ignite by itself because it doesn't vaporize.
Even diesel has a hard time. You have to use your glow plugs and various other things, and even
Yeah,
then it takes a long time to warm it up. So a lot of
and
times,
have the winter diesel.
yeah, a lot of times these vehicles will they'll just keep them running 24 hours a day in
Mhm.
the wintertime because if they get shut down and freeze, then it's a pretty big job. Like they literally put out like I think they call them tiger torches or something, where you're literally putting heat on the oil pan of the vehicle to warm up the oil to
Yeah.
the point where it'll actually flow. So,
Mhm. Yeah, I got to tell uh, academic war story. We had the Futures program at the University of Houston,
mhm.
and we had several Canadians from I forget which ministry, but they were future studies and things, and so we had a dinner at the dean's office, and a lot of Texans there. Of course, it's the University of Houston, and I was talking about that I had a plug on the front of my car, which was my it was like my block heater,
Right.
and the Texan said, "Yes, yes, yes." It's like you're telling a tall tale, like the Texan. And but fortunately, one of the Texans rescued me, and he said, "I have two plugs on my car. One is the block heater, and one is the." Or, I had a radiator. Excuse me, I had the radiator. So he said, "Yeah, I have a radiator heater, and I have a block heater for the oil pan."
Yeah.
It's like the Texans thought I. They sometimes tell tall tales, and they assumed that I was also because they had no conception of things. And this takes us back to the Mars Society. If they're going to, and Elon Musk, if they're going to build structures on Mars, they've got to test it all out at that low atmospheric pressure and those low temperatures.
Mhm.
Like that. The hinges on doors could freeze, or
Sure.
it's like it's not just water that freezes, the oil can freeze when it gets cold enough.
Mhm. Yeah, I mean, hinges on doors can be pretty simple. You just put on Teflon hinges, you should be okay. But I think Elon Musk is more focused, or at least Starlink, yeah, not Starlink, Starship, and SpaceX are more focused on getting to the moon at this point, just so that they can meet their
Yeah.
contractual obligations there.
Yeah. Well, the moon is like maybe the first day's drive when you're going on a long trip.
Exactly.
And back at Starlink, uh, that is a system that was supposed to cover all the Earth. I don't
Yeah.
not sure how far
You can
north
get
his latitude is.
you can get up to the north, like you said, they're not doing so much polar orbits, but the way that they launch them is kind of off to the northeast or something, and so they don't go typically over the North Pole, but they'll get above 60 degrees into the Arctic zones.
Yeah, doesn't matter if you're launching northwest or or southwest. When the orbit comes back up on the other side
Yeah,
of the globe, then it's going up north. But the point is that if he's got a utility that can cover Canada, then he might not be a money source. He might be somebody that wants to sabotage the project.
mm.
Like like Edison said, alternating current. It's a killer current. See, we're killing. You can kill an elephant, and they electrocuted an elephant, and
Yeah.
they invented the
Well,
electric.
just to be fair, though, that was a murderous elephant. So it
Oh,
was tried, and it was because it had killed somebody.
oh,
And
yeah.
so it was a judge decreed that it was to die, and they decided to execute it with electrocution.
I didn't know that part of the story. But anyway, uh, the point of all that is like you got to find uh, somebody that will pay money. You got to find a cash return on doing these things because they are expensive to build. And that was the thing that slowed. At the time, planes were much smaller, and you could build lots of them. Now, since then, planes have gotten as big as some of the original dirigibles.
Mhm.
But you got to start if you're starting a new dirigible industry. It's an expensive thing, and it's the inertia of getting something like that going. That might be the biggest thing. This thing about trying to get dirigibles going again has been talked about probably since the Hindenburg
Mhm.
went down. And it always comes back to it's expensive to do this, and when you get to going, the dirigibles only go maybe 80 or 100 miles an hour top end, whereas the planes, the jets now go, 500, 550,
Yeah.
and the dirigibles are uh, get in trouble if there's a thunderstorm.
Yeah. So
Shenandoah, the Akron, there were some
yeah,
other dirigibles that were lost in storms.
that brings up another topic of interest to me would be personal airships. So a one or two person airship that you can use for getting around the city
Mm,
has the benefit of not having not as likely to crash um, rapidly
mhm.
like a regular drone type vehicle, but you
Yeah,
could have the same kind of propulsion system and
yeah, that
just
was Santos Dumont. He would go along at low altitude. He would see the bistro that he wanted to go to for dinner. He'd wave to the maitre d'. They'd send a couple guys out. Dumont would throw out his line. They'd catch it, tie it to the lamppost. He would go down his ladder, have dinner, and then when he was done, he would go back up the ladder and go home. But now they do have multi-bladed little copters like the Aerojet, where Aero auto
there
gyro
are so
was in
many
the
of them
30s and
now.
40s. That was expected that everybody would have their auto gyros. Well, now there's multi blades, which can make it uh, quieter, and there's robotic things that could run them, and that's a lot better because you don't have this big thing. Even if
Yeah,
it's a one or two person craft, it's that's still a big thing to get
yeah.
caught in the air.
I don't know how much volume you would need to lift, 300 pounds of cargo. But anyway, I can
Mhm.
envision it being something that people would do as a hobby. And again, when it's not being used, you just compress the gas, and it's able to just sit on the ground like a car or a helicopter or something. But the big thing there is the same issue that UAVs and stuff are running into. The FAA and the Canadian equivalents have all these rules of what you have to do. If you're an ultralight, even if you're an ultralight, you got a bunch of rules that
Mhm.
you have to follow. So, one of the concerns I think is people flying low over other people's backyards. That affects privacy. And then, of course, you've
Mhm.
got safety.
Yeah,
And
the privacy issue's already been things. There's a famous video of this half naked woman with a big broom running after a drone.
the to make these systems work, and this is something Peter Diamandis talks about on his podcast, um, is that essentially the only way that it'll work is if we relinquish control of the vehicle to artificial intelligence so that it
Yeah,
can be certified and controlled, and people aren't going off on their own little flight paths, and they're not doing you know potentially illegal things, helping people break out of prison, whatever, this sort of
yeah.
stuff.
Well, that's also true. But the biggest danger was the uh, Joe Sixpack with an airplane that a car airplane that can go 200 miles an hour and get up to 10,000 feet. And there's an Aero Mexico a plane coming in for a
Yeah,
landing, and as happened with a private plane, a
sure.
guy had a heart attack, and the Aero Mexico plane was it crashed into it. That was about 1988 or
Yeah,
so.
yeah. And that was San Diego, right?
Yeah,
Yeah.
yeah, a little further north, John Wayne Airport. But yeah, so the smaller things, if they can only go 500 feet up, and as you say, they're controlled, and probably helicopter things are good enough if you're only going a little ways,
Yeah.
and the batteries get a little better. If you don't have this big balloon, then it will fit in the garage.
Well, yeah, I mean, the idea with the balloon is that the majority of I think the majority of the energy to fly an aircraft is to keep it aloft. So if you can help with the lifting force, like even let's say that you get half of your vertical lift from a balloon, it doesn't even have to be all of it. The rest of it you're getting from the propellers. So that means you can
Mhm.
have smaller propellers, right?
Yeah. Well, that goes along with John McPhee talked about the what was it, the pumpkin seed, something. There was a craft that was had some lift from its motion and was somewhat lighter than air.
Right.
And they thought they were going to be the future of aviation. They said, "Hey, it works. We've been testing it. We're flying it at a they had like a Cessna size flying pumpkin seed, but they could never get any more funding."
Yeah.
So
Like so many good ideas and a lot of bad ones.
who know? Who knows? Well, the engines are better. The electric batteries are better.
Yeah.
You want to get some a little zoom to take off. So
Well,
maybe
going
get
back
our
to,
pro from Manitoba, and
yeah,
we'll ask him about that.
going back to what I was saying earlier, hydrogen can be used as a fuel tank. So if you have it in gaseous form, so as you're flying along, you're just using up some of that fuel, but in the meantime, you're getting the bonus of some buoyancy out of it too. So
Hmm. It's like a little bit, yeah, less buoyancy doesn't always work. But
well,
anyway,
I mean, if you have I'm just imagining here like a six rotor or propeller
gee,
uh,
or
drone type
or
system.
8 or 12.
Sure,
I've
whatever.
seen a little
But they're
forest
being
balloon.
powered by hydrogen instead of a regular battery, and so in that case, you have enough power as long as you got enough fuel, and then
Hmm.
the lift that you're getting from the hydrogen is just a bonus.
Hmm. Or yeah, well, we'll think about it. Meanwhile, I think we've flown our hydrogen and cranes, airships, and whatnot. Although I do
Communication
what
systems.
the there's the hype can is stratospheric as well as aerostat stratospheric. My favorite was there was one of these countercultural hippie things in the late 70s, early 80s, and they were talking about you'd be in your dirigible in your hot tub, moving along sedately, and you'd be looking out the window at the ground below you as
Yeah,
you float sedately. And of course, they had no conception that a hot tub is
it's
this
pretty heavy.
massive amount of mass.
Yeah. Well, if we do have infinite resources, that's not an issue.
That's true. It could just be a fusion power thing to take your
There
hot
you
tub
go.
anywhere you want to go. But meanwhile, we'll see if we can make do with diesel fuel, maybe hydrogen straight on, maybe batteries getting better, and that's a whole thing too about the possible. Yeah, why lithium? Manganese has two valence
Sure.
degrees, so you should be able, with luck, you can have twice as much energy storage.
Aluminum's got three. I mean,
And aluminum
that's
has three, damn
so yeah,
it.
I agree. I don't know that lithium's necessarily the best source. And I mean, one of the things I'm hearing a lot about lately is the sodium battery. So that's not a bad option either, I don't think.
I've heard too, when, of course, the biggest thing is sodium and magnesium are both cheaper. Sodium in particular is
And more
much
abundant
cheaper than
than
lithium.
lithium.
And if it
Yeah,
gets in the environment, it's not, it's ends up being table salt.
exactly.
You get sodium carbonate, which is kind of a useful thing for glass and whatnot, but that's not a bad thing. And sodium chloride eventually gets a hold of chlorine, which it really wants.
Mhm.
But if you have lithium in large amounts in the environment, the only thing lithium's been used for is psychotropic drugs.
Mm.
So what happens if we have a big lithium spill? And it's Well, maybe
Everyone's going to feel
it'll be a
better,
lot
maybe.
mellower.
There you go.
Who knows? But it might not be good. I just a hunch.
Well,
Anyway, the
there have
hydrogen,
been
et cetera.
studies
Mm,
off topic here. There have been studies of all these pharmaceuticals that are being released into the environment and how they're affecting fish and other animals. And yeah,
mhm.
so we have apparently uninhibited fish and things like this, and so they're
Yeah,
more easy to catch by the birds and stuff. So
this is true. It goes up through the system. Anyway, uh, we're we've gotten pretty far up, and with hydrogen, and as we said, we discussed. We didn't argue, and hopefully we can get somebody that's actually studied these things in more detail
yeah,
and
well,
find out
send
some
me the
stuff.
link and we'll I'll put out the feelers and see what we can do. Might not
Okay,
happen next week, but hopefully we can set something up in the future here.
okay, sounds like a plan. All
Right.
right, thank you for your time, and I see some burgers have come my way, and
Oh, look at
and I
you,
have a
late
stew that
dinner.
should be just about right by now.
All right, well, have a good evening, and we'll touch base next week.
Okay, good night. Good night,
Okay, bye
everybody
now.
at the other end.
Good night, everyone.
Yeah, bye.